like to thank Dr. Charilu for inviting me. That the topic of climate change is so important for Indian agriculture now. It interests not only State Department people, scientists, students, staff, and even policy makers and even farmers also, because everybody wants to know what is really happening on the impacts, and then what is that the technologies are available, what technologies are available, what the government is doing, what extension people are supposed to do. So there's a whole gamut of people who are interested to know more about this. So I thought I'll be sharing a little bit on this, the impacts of climate change in agriculture, and what have been our experiences to cope with the climate change, and how to help farmers to minimize their losses that are caused by climate change. In fact, I started my career in ICR as a scientist in Jodhpur, that is a Central Arid Zone Research Institute, and then moved on to CRIDA, Hyderabad, on promotion again as a senior scientist. And then, of course, I moved up in the ladder as a principal scientist, then project coordinator, then director, and finally retired as a Vice-Chancellor. Now, all along my career, I have completely focused my work on dryland agriculture. Dryland and arid agriculture, both are more or less, where there is a acute water shortage, soils are very degraded, and you have very limited cropping window, and where the livestock plays a major role in farmers' income, etc. And so this has been my journey. But in the last, say, 10 years or so, 10, 15 years, a new dimension came to this dryland agriculture. Not only dryland agriculture, but Indian agriculture in general as a whole. That dimension is the climate change dimension. Till about 10 years ago, we were not taking climate change very seriously, in the sense that, there have been some changes and all, and globally there have been a lot of projects, and there is one organization called UNFCCC, United Nations Framework on Climate Change. They have been producing a lot of reports every 2-3 years. So globally, a lot of work is going on. And even in India, of course, India also, almost from 2010 onwards, the government has been focusing on this climate change, and they have formed 8 missions on climate change. And one of those missions is on sustainable agriculture, agriculture, and mission on Himalayas, mission on water. There are so many missions. So therefore, the government has been focusing, but when it comes to R&D, it's about 2010 or so, the ICR, the Indian Council of Agriculture Research, has thought about that, well, the climate change effects are now visible, they are very apparent, and every year the agriculture sector is losing anywhere between 1 to 4%, sometimes even 9% if there is an extreme event, very heavy rainfall or prolonged drought and all. So that being so, the council thought that we should have some long-term research strategy to cope with this climate change impacts on agriculture. And that is how the NICRA program was born, or the National Initiative on Climate Resilient Agriculture. Resilient word, resilient agriculture means basically when something is hit by some external parameter or external factor, then how quickly it can recover to the normal stage. That is what is resilience, So some people use the word climate smart agriculture. Some people use the word climate resilient agriculture. So both are more or less synonymously used, but there is a difference, That resilient agriculture, something will explain about the system's capacity to recoup to the original position. Therefore, as far as agriculture is concerned, in a practical sense, climate resilient agriculture is a better word than climate smart agriculture. Now, when the NICRA program was started, we had to look at the baseline. At that time, what were the actual impacts on, because when we say agriculture, it not only involves crop farming, but also livestock, fisheries, poultry, and even water, natural resources. Every aspect of agriculture is involved in when we say agriculture. So therefore, we initially had an assessment of what are the impacts of climate change on each of these sectors. But before I go to that, let me tell you that what really is meant by climate change. Because we generally use this term in a very general way, generic term. But from a scientist point of view or from a agriculture practitioner point of view, what really climate change means? Climate change means actually it's a long-term change in the average climate of a region. For example, yesterday it was cloudy, today it is sunny. That is not climate change. Or last year during June, July, we had a very heavy rain. This year that is also not climate change. That is climate variability. So year-to-year variability in a climate of a region is known as climate variability. But climate change is a long-term change. For example, if you compare, say, a 30-year period, where we had, say, for example, let us take Hyderabad, we can say between 1960 to 1990, we have X an average rainfall for a given region. But between 1990 to 2030, if you take another 30 years period, and if that X becomes X plus 1 or X minus 1, now then you can call it as climate change. So that way, the United Nations body, Indian government, ICAR, everybody has now come to the conclusion that climate change is happening, climate variability is also happening. Both are happening. In fact, what we are now seeing, what the general public are mostly aware or witnessing is the climate variability. That means suddenly in July, August having very long, dry spell and crops dying, or in September you have a very continuous rains and flooding happening, all vegetable crops, field crops getting damaged. No, that is variability, but both are important. And in fact, climate variability is equally important. These days, that is what is causing the damage. The second question is, once we know what is climate change, the next issue is why it is happening. It is happening because of human intervention. That is what we call scientifically anthropogenic. That means human-induced change. Now, just take one example. In 1750 or 1800s, 1900s, when the scientific measurements started, the carbon dioxide in the atmosphere was 360 or 330 ppm, 330 to 340, that was the range. But today, it is 420 ppm. Now, the average temperature of the Earth's atmosphere has increased by 1.4 degrees now, historically. Now, you may say, sir, 1.4 degrees is nothing. If you see day to day, it's not much. But average temperature increasing means in summer, instead of 40, continuously we may have 41, 42, 43, 45 sometimes. So in winter, where you are supposed to have a fairly pleasant kind of thing, the night temperatures may rise. So you may feel a lot of heat at the early morning. So the point is, the temperature has increased, the carbon dioxide concentration in the atmosphere has also increased. Why it has increased? The major drivers are greenhouse gas emissions. Now, these greenhouse gas emissions, there are many, but as far as the primary cause for temperature increase or carbon dioxide increase are four actually. One is the carbon dioxide, second is the nitrous oxide, third is the methane, and fourth, of course, is the fluorocarbons, which we are not so much concerned, but as far as agriculture is concerned, or the primary, the carbon dioxide, nitrous oxide and methane. Now, where from these greenhouse gases are coming? Carbon dioxide comes from, variety of sources, the industries, factory outlets, crop residue burning, soil, forest burning, so many sources. And methane mostly comes from animals. When the animals take, cellulosic diet in their stomach, then they have anaerobic digestion in their rumen. And as a result, methane actually emits. And third is, of course, nitrous oxide. And nitrous oxide mostly comes from the paddy cultivation. When you apply chemical fertilizers like urea, then some of it gets converted into nitrous oxide and goes into the atmosphere. So all these three greenhouse gases cause a warming or cause an increase in temperature. Now, there are two, aspects of climate change. Once we understood what is climate change, how it is caused, what are greenhouse gases, and where from they are coming. The next thing is what kind of impacts this temperature increase can have on our life or on agriculture, on livestock, on our travel, on our day-to-day life. Climate change does not impact agriculture alone. It impacts all walks of life. In fact, you will be surprised to know that now most of the industry, the tourism and travel industry, the software industry, everybody has some advisories, some experts attached to their industry on climate change. They want to know actually, for example, a thermal station, a power industry. They want to know in the next 10 days, how are the temperatures likely to be, so that how much power will be required. Accordingly, they will quote the price. Similarly, if there is a travel company, they want to schedule a travel program in a particular company in Middle East or anywhere, then they would like to know how is next 10 days climate will be. So this climate is such an important issue that every walks of life it actually influences. Now, as far as agriculture is concerned, what are the impacts? Now, in agriculture, it affects crops. There is no doubt on that. And it affects crops by what way? As you all know, you must have studied also, many of you, crop growth is very strongly influenced by temperature. So temperature, what is known as degree days, that is, for example, for a crop to grow from a seedling to flowering stage and mature, it needs certain degree of temperature every day, every week, every month, and for a continuous period. Now that temperature, there is an optimum temperature. As you know, for every biological organism, there is a minimum temperature, there is a maximum temperature, there is an optimum temperature. Optimum is what is good for its growth. Now, if the temperature goes beyond a tolerable limit, then what happens? The crop growth slows down. If growth slows down, it is okay. It will somehow, recoup after when the favorable conditions return. But the temperature is more during reproductive stage, during flowering, during grain filling, during pollination, during fertilization. If that time temperature increases, then the number of grains that are formed or the pollen grains that are germinated, they will decrease. So the yield comes down sharply. So therefore, temperature has a very strong negative effect on crops. That is how, in fact, it impacts yields. The second is an indirect effect through water. When the temperature increases, every degree rise in temperature will cause a 10% additional water requirement for irrigation. Because once there is a high temperature, then there is a more high evaporation from the soil and also on the transpirational loss. As a result, you need to add more water, you need to irrigate more water to the field. So that is an indirect impact, The third impact is that if there is a very heavy rain in a very short period, then what happens? It causes very high level of soil erosion. The topsoil gets washed off, it silts the reservoirs, water bodies and irrigation dams and all, huge loss. So that is an indirect effect again, Too much rain is also not good, too little rain is also not good. Both are problematic. And the third impact is, whenever there is a change in temperature or humidity or carbon dioxide concentration, the pest and disease incidence also sharply increases. So that also causes damage to the crops. So that way, it has a multifarious effects on the agriculture sector. Then coming to livestock sector, how does it impact animals? Animals have we have an optimum temperature, 37 degrees centigrade. You say the human beings are most comfortable at that temperature. Similarly, animals have a optimum temperature for their own, reproduction, growth and all that, feeding. Now, that is measured as THI, thermal humidity index. Now, if the temperature and humidity combination THI increases beyond 70, then animals have a discomfort level. So if the temperature increases more and more, then they have more discomfort. And finally, a stage comes where they will, not able to eat, or the feeding will come down. They will not be able to give that much milk as they would have normally given in a comfortable condition. So therefore, animals also are all affected, and now there are a lot of studies which show that by 2030, we may lose as much as 10 to 15% of our milk production in this country if the temperature increase or if the climate change goes without any, in the same way, in a business as usual scenario. Of course, these are only estimates, but otherwise, climate change impacts currently can be studied. But in future, if you want to know what is going to happen in 30 years from now, 40 years from now, you can only do by modeling. Modeling means based on what has happened in the past, we predict what is going to happen in the future. Now that is a modeling, and models can go wrong also sometimes, little bit. So there is an error also, plus minus. But the whole world now, climate change impacts are mostly assessed or studied by modeling. Now most of the modeling studies project a negative impact on crops, a negative impact on animals, negative impact on water resources, negative impact on poultry, etc., etc. But surprisingly, there are some regions and some crops within India which may even get benefited. For example, crops grown in temperate regions like Kashmir, Uttarakhand, Himachal, where the temperatures are quite low at this point of time, there the crops may even benefit a little bit. Even some crops across the country like chickpea, the Bengal gram, chana, that also may be benefited. So legumes generally, they get little bit positive impacts. But otherwise, main crops like rice, wheat, maize, sorghum, these are all going to be negatively impacted. Now, this is about the impacts. So, we understood now what is climate change, why it is caused, and what are its impact. Okay. Now, the next point is, what is that we can do? Can we stop climate change? That is a big question. So, the answer is yes or no. Yes, because in the climate change, there are two terms, which are very commonly used. One is adaptation, second is mitigation. Now, adaptation is something we try to adapt to the change that is already happening. For example, in this area, there is a drought. So, we try to grow a drought-tolerant crop variety. Now, that is called adaptation. Okay. In our own case, supposing there is a very cold outside, we have a sweater or we have a coat. That is adaptation. We try to adjust to the situation that is outside. Mitigation is to stop the change itself. For example, if the temperature is increasing, why it is increasing? As I told you, greenhouse gases. So to reduce or to minimize or stop the emission of greenhouse gases, if we can do that, that is mitigation. So adaptation is mostly locally done. I mean, for example, if there is a problem in Hyderabad, we try to find a solution which works here. But mitigation has to be done globally or nationally. Because if you stop burning some crop residue here in Hyderabad, it won't help. Everybody in India, every other country has to participate in mitigation. And that is why for mitigation, there is a global effort. This whole Kyoto Protocol, Paris Agreement, Glasgow Agreement, all these dialogues, discussions, agreements are all meant for mitigation. They want to bring every country on the platform and convince them that unless we mitigate this greenhouse gas emissions, the whole world is going to be at risk in future. And that is how the efforts are going on. And every country commits, so they have some agreements that India has committed that we will reach net zero by 2070 or so. Net zero means because emissions cannot be stopped totally. Because when we running a vehicle, the exhaust is bound to come. When we are burning a crop or we are growing a crop, when there is some soil tillage, there will be some respiration. So when we are running in industry, the emissions will come. So that is something. But the point is, can we neutralize that by making some positive contribution to the atmosphere? For example, simple example is when you burn a crop residue, it emits carbon dioxide. But when you grow a tree, then you will fix that carbon dioxide into the soil. So you have to equalize these two. So that is what is the whole efforts of net zero. Net zero means from all the sectors of agriculture it contributes only about 14% to the total GHG emissions in our country. Most emissions are coming from energy sector. From thermal stations, from transport is the biggest contributor. All those vehicles that are running in the country, all of them emit carbon dioxide. Similarly, all the animals which we have in our country, we have the largest livestock population, and they all emit methane, and which we cannot stop because after all, it's a natural process. Similarly, nitrous oxide from fertilizer use. So there we can do some intervention. So like that, this mitigation is something which is required to be globally done. And but India has committed both mitigation as a leader of the developing countries and also adaptation. Several steps are being taken for adaptation as well. In fact, all our research projects in ICR or in universities, all this research is basically 80% is for adaptation. Because our production of, development of drought-tolerant varieties, flood-tolerant varieties, submergence-tolerant varieties, and, varieties that mature early so that you escape the late-season drought. All these efforts are basically, or some feed supplements in livestock so that the livestock methane emissions comes down. So all these are research programs or technologies which actually help in adaptation of agriculture, both crops, livestock, poultry, etc., to the impacts of climate change. So all our research programs across the country have been aimed at this single issue of adaptation and of course simultaneously mitigation as well. Because India also, as I said, part of the Paris Agreement, a signatory, we are contributing to our best to the mitigation as well. Now, if you come back to the number of technologies or the type of technologies, how they are actually being used by the farmers, and in future what kind of further issues that may rise, and what is the response of the research and university system to address those issues, let us discuss. For example, we have been in our Indian research system in agriculture for several years. We have this program on development of drought tolerant varieties, short duration varieties which are photo insensitive, thermo. So all these programs are in place. We are now combining all these into climate resilient variety. That means now recently ICR has taken a decision that in future all the crop varieties that are likely to be released at national level or state level, we must have a component of climate resilience as one of the important trait, along with yield, along with pest resistance, along with the disease resistance, along with better nutritional quality. Along with all these qualities, the variety also should have climate resilience as an important element. Now, what do we mean by the climate resilience? That means whatever area that variety is recommended in that area, if the drought is a major issue, then this variety should be able to tolerate drought to a large extent, so that it should not fail because of drought incidents. Similarly, if a variety is recommended for an area like Assam, where there are continuous heavy rains and continuous floods, in that case, the variety should be able to tolerate waterlogging for some period, maybe 7 days, 10 days, depending on the area. So that is what is climate resilience. And not only tolerate, but also recover quickly once the water recedes. Recover quickly once the drought, when the rainfall resumes. That is the kind of, thinking. So that is what is now going on. In fact, let me tell you one very good example of paddy variety in waterlogged areas. For example, there is one Swarna. You all know it's a most popular variety in our country and grown in very large area. And Swarna, it is a very good variety, but whenever there is a heavy rains, it gets damaged very quickly. Waterlogging, or especially in coastal areas, cyclones we often encounter. So for that issue, a new variety has been developed, called Swarna Sub-1. It's a Sub-1 is a gene which has been introduced into Swarna variety, and now the variety is called Swarna Sub-1. And this Swarna Sub-1 can take, waterlogging for more than 7 days. 7 to 10 days if there is a standing water in the field. If the crop totally gets submerged, also it will survive, and once the water recedes, it will again start growing. So a great contribution of the scientific community to the flood affected areas. Similarly, we have so many drought tolerant varieties, not only in paddy, but in several crops. In fact, so even if there is a 10 days, 15 days dry spell, the crop will not die. It will remain, but it will grow slowly or it will stop growing. But once the rain resumes, it will again pick up very fast and then give the as much yield as it would have otherwise given in a normal condition. So that is another thing. Similarly, nowadays, there is sort of observation that the monsoon season in India is getting delayed. In most parts, that in states, suppose if a normal date of sowing is June 10th or June 14th, but it varies depending on the onset date. And continuously, we are now observing that in the monsoon getting delayed. And once the monsoon getting delayed, then your date of planting also gets delayed. Because most of the crops we have been observing that it requires some particular duration, 90 days, 80 days, 100 days. Once you delay the sowing, then your duration crop growth window becomes narrow. It gets less. And then the crop yield goes down. Therefore, now our scientists have come out with varieties which are suitable even for a delayed planting. Even if you lose 10 days, 15 days, the variety gives as much yield as would have otherwise given. That is one strategy, what we call as contingency planning. In fact, CRIDA, ICR, Ministry of Agriculture, you must have all been aware fully that all the more than 600 districts, district level contingency plans have been prepared. And these contingency plans are basically to address the climate variability, to address the monsoon aberrations. Whether the monsoon delays by 15 days, sometimes it can delay even by 1 month in some locations. Not that all over India it can happen. And also the monsoon can withdraw earlier than normal time. So in that case, what to do? Or the third possibility is that the monsoon, there can be a long break in the middle of the growing season. The other possibility is that when the crop is just at the reproductive stage, there can be heavy rain for 10-15 days continuously. The soil gets waterlogged and there is no sunshine, then a lot of pest disease problems. So all these are issues that are caused by climate. So to cope with these, the contingency plans have been prepared. So what is the choice of variety? If there is a delay of 15 days or 30 days, or if it is a beyond 30 days, if you cannot change the variety, you can no more grow that particular crop, then you can grow another crop. As such, by its nature, very short duration. So that is another way of coping with the delay in monsoon. Similarly, in case of mid-season droughts or when there is a dry spell in the middle of the season, then there are so many recommendations, some foliar spray of growth regulators, mulching, and then also land modification, bed and furrow system, raised bed planting. So like that, you conserve the rainwater where it falls and somehow help the farmer to overcome the dry spells. Or more importantly, you also, do the water harvesting in many areas, people can, because as we know, climate variability, one of the main thing is that when the rain comes, it falls very heavily. So that time, you harvest the surplus rainwater in ponds or reservoirs, and then use it when there is a dry spell, either by lifting or by gravity, whatever way it is possible. Or you can recharge the groundwater. So there are so many ways. Ultimately, the point is that whenever there is a dry spell in the middle of the season, then you can take up a lot of measures so that you can save the crop and help the farmer to cut down his losses. So this is what is the concept of contingency crop planning. This is very, very important component in climate resilience. Then the another important climate resilience is water management. You all know, as I told you earlier, that when there is a high temperature, high evaporation, high transpiration, then you need more water. So then you have to again, adopt most efficient methods of irrigation. Of course, micro irrigation, we all know, drip and sprinklers and, all that technologies, and they are very relevant for, climate resilient agriculture. And also demand management, how to rationalize the use of water, what crop choice, where a particular crop, suppose in a dry area, should we grow a water guzzling crop like sugarcane? These are all more of policy dimensions, but all these come into place. That when you have limited water and you want to saving the crop, then you have to use it most efficiently and also adopt a cropping system which is most water efficient, which does not waste water. So this is another way of saving on water and efficient water. So efficient water management and right crop, right variety, right cropping system, and right agronomy, all these are components of climate resilient agriculture as far as crops are concerned. As far as the livestock concerned, of course, 2-3 interventions have become very clear by now. One is the shelter management, because in livestock the most important is the heat, because summer, extended summers, very high temperatures, then at that time the shelter becomes very important. And now our animal scientists have come out with a lot of models of shelter which are very low cost, which can be done by the farmer himself, or with some assistance for the government. He can also improve the shelter for all animals, for cows, for buffaloes, for small ruminants, for poultry, for pigs, all. And second is the feed management. In ICAR, many institutes have come out with feed supplements and feed formulations which actually help the animal to cope with heat stress. In fact, in poultry, they are very successful, that you feed these along with the regular feed, then the animal will be able to take the heat load, heat stress externally a little better. And so that the loss of milk production, loss of meat production, loss of growth, reproduction, etc. will be minimum. So that is how you can manage this thing. Whereas similarly, fishery sector also, you will be surprised that along with our temperatures on the earth, the ocean temperature also have been increasing. More than 1 degree now. Sea surface temperature, it is called SST. So the SST also has increased historically. And so therefore, because of that SST, the fish that are actually living in the oceans, or the marine fish, they also have a problem of spawning. Spawning means egg laying. So they have, for reproduction, they also have a problem. So therefore, what they are doing now, because unlike some other animals, the fish are highly mobile. They can migrate. So they are now migrating from a high temperature zone to a low temperature zone within the ocean atmosphere. So that also is being observed. Of course, but we cannot do much in case of marine, but in case of freshwater fisheries, high temperature in the water bodies or in the atmosphere is causing problem in reproduction. Then people are trying various, again, there are also feed supplements. And then, of course, when you do the culture fisheries, then things are under your control. You can control the temperature and all that. So that way, all sectors, be it poultry. In fact, in case of poultry, you'll be surprised to know, about till 10 years ago, whenever there was a very intense heat in the May, there used to be huge mortality of poultry birds across the country, millions of birds. But after that, within 5-6 years, the poultry being a commercial venture, and most of the poultry farms, they are managed by people who can put more money in technology. So they have now come out with very different methods of cooling the poultry sheds, either by simple gunny bag covering and all, or putting some foggers and sprinkling water. So nowadays, in the last 5-6 years, we don't see much poultry birds mortality because of heat. Of course, there is still mortality due to diseases. That's a different issue. But climate-induced, mortality has now come down significantly in poultry. So that way, both, the agriculture, livestock, poultry, all sectors, now we are able to, have some technologies to minimize because, we cannot totally, as I said, completely eliminate the impacts of climate change, especially the extreme events. Now, in the last decade, extreme events have become more problematic to handle. Extreme events means, what do you mean by extreme events? That means, suppose if in a given region, normally in a day, you will have 50 millimeters rainfall. But suddenly, if you have 200 millimeters rainfall on a single day, sometimes not a single day, sometimes few hours, then what happens? The soil or the agriculture fields or the irrigation dams or irrigation canals, they cannot take that much rain in a short period. Then everything gets damaged. The canals breach, the ponds breach, lakes breach, tanks breach, and the crops also get damaged. Everything gets. So those are now a big problematic. First of all, it is difficult to predict extreme events. Our meteorological knowledge is not enough to predict extreme events accurately. Second is, even if we predict our response time and response technology, we don't have that much. Therefore, extreme events continue to cause damage. And this is what is actually now the research community is worried that as to how to cope with these extreme events and what type of infrastructure we should have. Because a variety, we can develop to some extent in waterlogging, but other things are still a problem. So that is one area where we still have, long way to go, managing extreme events. Another thing is managing hailstorms. Because earlier, hailstorms used to be limited to a particular period or particular district or particular taluka and all. But the last 10 years, if you see, the frequency and intensity of hailstorms has increased very much. Sometimes they are occurring from Himachal Pradesh to Maharashtra, continuously belt. So hailstorms are again difficult to handle. There are some technologies, the hail covers, hail guns and all, but they are still not yet been widely used by the farmers. So this is another extreme events, hailstorms, another which are affecting agriculture. Then once we know that a particular region is vulnerable, then the government can invest. So therefore now the ICR has also done some vulnerability mapping. That entire country, district level, they have been mapped. Which are the areas which are mostly drought prone, which are the areas which are waterlogging prone, which are the areas, temperature heat wave prone. So that this mapping has been done now. And district level mapping is available in most of the state governments, this atlas. There is an atlas called Vulnerability of Indian Agriculture to Climate Change. Now this is a very good atlas. At district level, you will get information on what is the impact each district is most vulnerable. So that accordingly, if your particular district which you are interested is vulnerable to drought, then you can take technologies that are helpful for managing drought or coping with drought. If it is a heat wave prone, for example, 2022 Rabi, what happened in India? We had a severe heat wave in northwest India, in Punjab, Haryana, Himachal Pradesh, Rajasthan, etc. And the average minimum temperature during grain filling remained more than 2-3 degrees higher for a very extended period, for more than 2-3 weeks. As a result, the grain filling duration has come down and grain size has come down, and as per the Government of India's report, also have come down more than 4 to 5%. And because of that, the heat wave, one single incident for a week has caused such an impact. So therefore, managing in a particular area, the particular climatic stress is very important. And for that, of course, luckily, the damage would have been much more had ICR universities have not developed the heat-tolerant varieties. Now we have a lot of heat-tolerant varieties, and farmers who grew these heat-tolerant wheat varieties, their loss was much less, very less compared to the farmers who did not grow these varieties. Similarly, farmers who adopted intercropping, farmers who adopted, sprinkler irrigation, there are a package of practices recommended for managing heat stress. Those who adopted those technologies, they were able to minimize the losses as compared to those who did not adopt. So that means, that when a real event happens, there are technologies, but what is important is that the extension staff, other people have to be more aware of these package of practices for managing heat stress, and then take them into the farmers in much more widely and make them aware. Same is with drought, same is with waterlogging, same is with hailstorm, same is with continuous heavy rains. So this is the kind of picture. So now we have understood what is climate change, why it is caused, what are its impacts, and what are the technologies available. Now to take these technologies to the farmers' fields, there are different strategies. One is, of course, some national level projects which demonstrate these technologies on the farmers' fields through KVKs. NICRA is one example. NICRA is actually doing that in more than 150 villages. That is more of a demonstration. But beyond that, the state agriculture department extension staff have a major role, because they have to see themselves, how in these model villages or in the NICRA villages, how these technologies are being demonstrated. What is the response of farmers what resources are required to implement them at the village level or at the block level, at the district level. So this whole assessment has to be made by the department people. And for that, not only need inputs, but also need knowledge, inputs, and sort of, the whole package of practices. And one simple example, just to make you understand, in Bihar, there are many places which grow rain-fed paddy, rain-fed rice. They raise the nursery only after the rain comes. And then they transplant after 15 days, 20 days, as per the variety. Now, what is happening? Once the monsoon gets delayed, then the nursery raising gets delayed, transplanting also gets delayed. So for that, one solution which NICRA has demonstrated is community nursery. That means in a village, every farmer may not have water resource, but few farmers may have some tube wells or some open wells. So pool the resources and raise a larger nursery instead of, suppose a normal farmer, if I want to raise my own nursery, I will do only in few cents. But if some 10-15 farmers pool their resources, their seed and all, and then contribute little bit money for each, and then at one place you raise the nursery in time, irrespective of the monsoon. Whether the monsoon starts or not, with water resources, you start the nursery. And then once the rain comes, then you have a lot of water. Then all people can transplant simultaneously. I mean, on time. Not exactly the same day, but at least within a window of 1 week or so. So this is the concept of community nursery. This is just one example. How you can, overcome the problem of monsoon delay. Second is that if there is a monsoon delay and if people cannot do all this, then what is the other alternative crop, best crop, which will give you almost equal returns? And for that, people grow sometimes black gram. Black gram is a very good crop, delayed sowing, even in July. So like that, there are some crops which are recommended for each region in those model villages. And or you can also do some intercropping, so that even if there is a delay, you still grow paddy plus some more short duration pulse or oilseed crop, so that if the paddy gives less yield, it will be compensated by the yield that is obtained from the intercrop. So that way, there are ways, and all these are demonstrated in the model villages. And also the water management practices, raised bed planting and water harvesting, all this, foliar spray of growth irrigation. So all these are demonstrated in the villages. And it is up to the extension staff to understand these practices, how they are actually, and maybe that if we recommend 10 practices, farmer may not be able to practice all of them, because he may not have resources, he may not have the labor, so he may not have the machinery. So as a result, but even if some of them, so it is up to the extension staff to understand how many of those practices which are recommended by the universities or the ICAR institutes are easily doable and which are more cost effective. You do spend 1 rupee, but you get at least 2-3 rupees. Some may require more investment, some may require more labor. So it all depends. So the extension staff can really make a good judgment, very good informed judgment as to which are the technologies from this climate resilient agriculture we can take to the farmer and convince him to adopt. And globally also, in India at least, one technology which has proven time and again is the integrated farming system approach or model. That means encourage the farmers to go for other than crop also, because crop alone, despite your all efforts, will not be able to sustain the farmer's requirement, a household requirement for income and employment and all. So along with the crops, if you have livestock component, some horticulture component, fishery, duckery and poultry, depending on the region, because you may not be able to do fishery everywhere, but in Orissa, Jharkhand, West Bengal, you can very well do, even in Andhra Pradesh, you can have rice fish culture. You can also have rice duck, very common in Jharkhand, Chhattisgarh. So you can have poultry almost all over India, along with backyard poultry or even a semi-cage poultry. So you can have variety of, and you can also have small ruminants. Small ruminants are not very expensive to raise and manage. So that way, if you have along with crop another additional component, then household, his income. In that case, what happens if because of abnormality, crop totally lost, he will still get some income from the poultry, some income from the livestock, etc. So therefore, this is another issue which the extension staff has to understand, that the importance of cropping system and also importance of farming system, importance of integrated farming system. This is something on which there is a complete consensus. In fact, this is something which the Western countries, in fact, look to India. This intercropping system, farming system, these have almost disappeared long back in Western countries. They have completely gone for mechanized monoculture because the labor is almost very less there. Family, only one person does agriculture on thousands of hectares. But in our country, still, despite all the labor problems which we also face, still in our country, we still have this concept of crop with animal, crop with fishery, crop with... So this is something we have to nurture, we have to preserve, we have to promote in our country in order to make our agriculture climate resilient. This is an important, very important message. Another very important issue or the resilience component is the agro advisories. Giving weather agro advisory to the farmer in the right time. Because any amount of knowledge, unless it reaches the farmers in time, it is of little use. We all know that. So therefore, the KVKs or the universities or even the departments, because even in Maharashtra, millions of farmers are provided agro advisories by the State Department itself. And also many private companies. I don't want to name any company, but there are many companies which are also disseminating agro advisories. Now, giving a routine agro advisory is one thing, but giving an advisory to cope with a climate is something different, and it is more complicated. And this is where the state governments also have to graduate from a normal advisory to an advisory which will help the farmers to cope with a contingency. So that is, I think, a lot of capacity building is required at the state level so that they alert the farmer in time. Yeah, this is going to happen. For example, in coastal Andhra, for example, if you can alert the farmer about a cyclone, that next 2-3 days a big cyclone is going to hit, and do not harvest your crop. It's the biggest contribution if you can do it and farmers can really adopt it. Because if you harvest a crop and put it on the ground, many times it has happened when there is a continuous rain, the farmer cannot enter into the field, the whole thing gets washed into the Bay of Bengal. This happened several times in Orissa, in West Bengal, in Andhra, Tamil Nadu. Now there, if you can give an advisory in time so that the farmers do not harvest the crop. Similarly, if there is going to be very heavy rain and the farmer advised not to not to apply any fertilizer, then also he will save on the inputs. Because if he applies fertilizers and next 2-3, everything is lost. Same is pesticide. It doesn't serve the purpose. But advising the farmer at the right time is very important. Not only advising in radio, television, but ensuring that the message actually reaches him. Of course, some NGOs and all, they are trying to get these messages written on the panchayat level, on the boards or on the walls and all. It's happening. But all these have a greater role, very big role in climate resilient agriculture. Because taking the message to the right person, to the right time is very important. So one is technology, second is the agro-advisory, and third is the extension, which we discussed. That is, the extension people themselves have to be, capacity building has to be happening there and they have to reach. And fourth, of course, is the risk management through insurance. And in fact, in many countries of the world, including US and Europe and all, their major strategy to cope with climate change is insurance. They don't so much involve in extension and all, because there the farmers are more like businessmen. They are well educated, so they all know the importance of insurance, weather insurance, and they buy the insurance. Almost there is no farmer in US who does not buy insurance in US. So they get compensated when there is, because entire country will not be hit simultaneously by any weather event. So therefore some people lose, some people gain. So the premium which is paid is used to pay. But in our country, weather insurance came about a decade ago, and somehow it did not penetrate. Of course, now it is made part of the, I think, PM Prime Minister Fasal Bima Yojana, but I do not know whether weather-based insurance is still separately being practiced or not. But basically, we also need a very strong insurance product, very strong, very relevant, very farmer friendly. Because if you say farmer friendly, it doesn't mean that every year farmer pays premium and he will get 4 times money as a payout. In that case, insurance company will go sick. So the insurance system has to be such that the farmer gets reasonable risk coverage. At the same time, the company also survives. Both have to happen so that long term the risk is managed. So this is where again the extension staff role comes. To educate the farmers what are the risk management products that are available in the market and guide him properly that you can take this, you will cover this risk, you can take this, you cover this risk. And even normal insurance policy also will cover this kind of risks also. So this is another strategy. Finally, it is the long-term investment with the government which helps in coping with climate. Because investment on irrigation, investment on rainwater harvesting, investment on soil management. For example, if you want to do some long-term water management system, then you cannot do in 1 year. You have to invest on all water conservation, National Watershed Development Program, and similarly MG Narega. In MG Narega also we have a lot of opportunities. In fact, this is one of the best programs to take up climate resilient agriculture programs across the country in a decentralized manner. All the activities that are listed in MG Narega are very useful for climate resilience. All the desilting, cleaning of all the nalas or water conservation, bunding, check dams, on-farm reservoirs, ponds, all are very relevant. That's where the people who are involved at the village level, block level, district level, who are in charge of this MG Narega program, to dovetail it so that it helps in building infrastructure for climate resilient agriculture. So that is another dimension. So the government always need not invest on a new program. Even the existing programs, if they can be dovetailed, if they can be made to converge to help in climate resilient infrastructure. Because climate resilient infrastructure is something mostly to do with natural resources. Of course, seed and all, they are made available by the government, seed corporations and all that. But that is also not in place. For example, if we recommend a climate resilient variety of rice or tur, whatever it is, but timely, if the farmer wants that particular variety, he should be able to buy it or he should be able to access it. Many times the state departments also, they cannot provide with short notice because right in March, April, you don't know how the monsoon is going to be exactly. IMD gives some broad forecast, but exactly whether the monsoon is going to delay by 15 days, 30 days, 40 days, we don't know. When it comes, when you know that very short notice you don't have much notice. So therefore, my suggestion is, rather we have actually thought on this some 10 years ago, but somehow it didn't come into practice, is having seed banks. Suppose you have a particular variety which is widely recommended to replace a normal crop in case of monsoon delay, then produce that seed of that particular variety or a crop and then store it in a central place so that within a 1 week notice you should be able to mobilize that seed and distribute it to the State Department of Agriculture people in a large area, very short notice. But then question comes, suppose if the monsoon turns out to be normal, then what you do with that seed? That seed can be disposed as a grain, normal grain, and the difference between the seed price and the grain price, I think the government can bear. That much, the government, instead of paying huge amount as a compensation after the damage is done, if some investment can be made on both on the infrastructure and on the price difference, if the government can pay, I think this is just one idea. But the State Department people, the Commissioner of Agriculture, the secretaries, based on the principle of contingency planning, based on understanding what is required to be done, what resources are required, what is the time window that is available, you should yourself innovate. You should think how to come out with new scheme or new incentive scheme, and also how to dovetail the existing schemes. All that the state level thinking has to go. And in Odisha, I saw one example there, sometimes some 5 years ago, they have really thought on this. And before monsoon every year, they come out with a state level contingency plan. And they make all the state level joint directors of agriculture, district level officers, block level officers aware of this, the climate variability, and what to do in case. So they are authorized to spend, authorized to use resources, buy things well in advance. And that is very, very important for a state to take up timely measure. And this should happen across the country. Why not? Because, this is a very important issue, climate vulnerability and agriculture. Both are important subjects, and farmer. All three are very important dimensions in our country. So therefore we must do that. I think this is something which the government, I think in future will do. And the only thing is, we manage has a big role in bringing this awareness in all the state level, at district level, officers, and even top level civil servants. In fact, I would suggest you should conduct a training for all the secretaries of agriculture only on this issue, that how to cope with climate variability, climate change, weather aberration, monsoon delays, how to manage this in your state or in your area of work. What is the role of secretary, commissioner of agriculture, then joint director of agriculture, district level, then block level office. Everybody has a role, and that role they have to be made aware. And once they are made aware, then they must raise a demand to the government, yes, to the state, that this is our plan for this year and these are the resources required. And then the government definitely will not back out. If you go with a solid proposal backed by strong evidence, strong experience of the last few years, then the government will not say no. They may not give you all the money that you demand, but at least, and once you start this process, then in a few years you will gain your own internal experience, and that internal experience is very valuable, because you know where you have gone wrong, what works, what does not work, and accordingly the whole process, the protocol gets refined internally within yourself, within your own department, and that is the most valuable than any training you undergo. Internal experience based on protocol, your own based on experience, and within the government system one can innovate. Definitely it is possible. So this is another dimension of the whole thing, how to cope with climate change and how to get it implemented at different levels in the government system. This is also possible. Then this district level contingency plans, then this change of variety, all these things, when we talk about this at any international training programs and all, many countries from Africa, Latin America, even within South Asia, in fact Sri Lanka, Bangladesh, they have shown interest, and our, I think, expertise has been shared already to how to prepare, because in our country, district is a very, very crucial administrative unit for anything to be done related to agriculture, for that matter on anything, even revenue. So district level, if you can plan and do something, it will really change. It will really can be implemented. So this is in most of the South Asian countries also the same thing. Now they are also taking these experiences from India, that what can be done, what resources are required, how to plan and how to implement. Once these experiences are because more important is documentation. Suppose we do a district level or state level experience, this whole thing has to be documented. It should not be person oriented. Suppose a very enthusiastic and motivated secretary is there, IAS officer is there, he can make everything happen. But as long as he is there 1 or 2 years, after that nowhere it is documented, then things will go back to the normal. So it has to be documented and prepared as a protocol. And this protocol has to be available in the State Department of Agriculture. So that any secretary who comes later on, any commissioner who comes later on, need to refer this. In fact, during British time, there used to be famine code. What to do when there is a dry spell, how to organize animal camps, livestock camps, how to feed people, how to provide employment work. So like that, there has to be a code. We have drought code. Of course, the Ministry of Agriculture has already come out with a drought code. Now my idea is that you should also come out with a climate management code. Of course, we also have a disaster codes. But disaster codes are more to do with infrastructure damage. But soft damage to agriculture during climate variability, climate management code. We should have a code, and that code should be published and made available, can be even approved by the assembly. It's a very important issue. What I am talking is an important issue. As far as agriculture is concerned, nowadays, of course, if you ask any farmer, he will say the biggest, of course, is the price. He will say that I am not getting enough price and all that. That is something a market is not related to climate that much. But other risk, next risk he says is the climate. For example, last year in Telangana, farmers had an excellent crop up to flowering, good vegetable crop. But once the heavy rains completely damaged. Same is cotton, same is paddy. It was about to be harvested, or even harvested paddy completely submerged. So this is no more an issue which can be ignored. This is an issue which is very serious, which we have to take seriously. We have to put institutions in place. We have to put systems in place. We have to commit resources to address this issue. So all this needs to happen. And this, of course, slowly will happen. But the role of manage is to highlight the importance and seriousness of this issue, and also guide the people at the state level, options that are available to address this issue in terms of management, in terms of finances, in terms of using the existing schemes for convergence, and bring additional resources wherever genuinely required. So this is something which the manage really need to do. So that is my sort of final message. So thank you very much.